Hey, and welcome to our module on scanning. In the previous module, we covered the first step in the hacking process, which is footprinting or recon, where you collected information about your target. Step 1 is gathering a lot of information, easily available. Step 2 is actually taking more of an active step in it, scanning your target to get you to step 3, to ultimately get you to step 4, hacking your objective. Scanning is a process where you probe a target's network with the intent of revealing useful information to use in your penetration tests. So what type of information could we find during the scanning process? We could find out how many hosts they have. Are they up? Are they down? Are they powered on? Are they connected to the internet? Are there firewalls, routers, other devices possibly? Printers? Internet of Things devices, maybe some cameras, maybe we can piggyback off of one of their IoT, which is Internet of Things. We can piggyback on one of their IoT devices and get in. Maybe we can install some malware that way. We can maybe find out a little bit more about what kind of vulnerabilities are going to be open or available. Open ports, operating systems, patches, systems architecture. Scanning is going to reveal a ton of information that will help you create a map of your target's network and get a better picture of what you're going after. In this module, we're going to learn about the different types of scans: network scans, port scans, vulnerability scans, cat scans, dog scans, scans. Each provides a different level of information about the target's network. Network scans locate live hosts on a network. Port scans probe those hosts looking for open ports. Vulnerability scans identify vulnerabilities. And if you guessed that, you're my favorite. I'll cover each of these scans in more depth in this module, including the best tools for each type of scan, or at least the most used and widely recommended. Specifically, we're going to look at LAN, MAC, and IP scanners, Nmap, a very popular free open source port scanner, which is included with Kali Linux. Nmap was designed to rapidly scan large networks to determine dozens of important network details, and it's awesome. Another tool is HPing3, which enables the creation of custom packets to send to your target, looking for specific responses, which can give you more information about what operating system they're using and different things like that. We're going to look at Nexpose, which looks for a specific set of weaknesses. Wireshark, which captures data on a network, and you can actually use that to, there's so many different things you use Wireshark for. You can use it in any networking application. And then we're going to look at Maltego, which returns information about what services are running. It's a social engineering sort of platform. Oh man, Maltego is really cool. In the final video of this module, I'll demo using some of these tools, and you get to try them out yourself in the test lab environment. All right. Let's move on to the next lecture, where we're going to learn about network, port, and vulnerability scanning. Scanning is designed to reveal the details and vulnerabilities of networks and different types of systems. Not all scans are created equal, however, and in this video, I'll make sure you understand the different types of scans that are out there, the types of scanners, software, what their strengths and weaknesses are, and when to use each of them. You'll typically start with a network scan, which locates live hosts on a network. Live meaning they're running, up, powered on. For example, in the footprinting phase, you may have found the IPs that your target uses, but you need to do a network scan to know which IPs actually have a host behind them. You could use ping sweep, which rapidly scans a range of IPs and determines if an address has a live host attached or not. Pinging is commonly used for pen testing in initial scanning. And actually, it's often used in just general networking to make sure things are up or not. It's really, really simple. What it really does is sends a message request to another IP, and if that system is live, it replies back to you. The reply confirms that the IP is live and reveals the speed of the connection, which is why pinging is used by internet speed tests. You can perform a ping or a ping sweep using Nmap. You can actually run it from command prompt in Windows. Nmap is a tool we're going to actually discuss, I believe, in the next lecture. Keep in mind that pinging doesn't truly detect that a system is down It just returns that it couldn't reach the host, which doesn't necessarily mean it's down. Many network administrators block pings at the firewall, so the lack of response could indicate firewall, not down system, or, if you're a fan of rock, system of a down. Also, larger or enterprise environments might even have like IDS or intrusion detection systems that detect your ping sweep and alert the system owner, or they just shut down the scan and you don't get any results. Usually that kind of thing is kind of frustrating, not getting any confirmation back and just sort of the ambiguous gray area. A more advanced pinging tool is HPing3. A basic ping sends an ICMP packet echo request, while HPing3 can craft customized packets to elicit different responses from the target system. HPing3 enables you to try a wider range of strategies when network scanning, and even attempt firewall and IDS evasion techniques. It's a pretty sophisticated tool. HPing3 can perform network scans, port scans, and that's what we're going to be discussing next. Once you've done a network scan and know which IPs are live, you'll want to find open ports with potential vulnerabilities. Port scans are designed to probe ports with the intent of learning more. To understand port scans, we need to review the TCP connection's three-way handshake, which is engineered to establish a successful and reliable connection between two systems. Let's take a closer look at the steps to see what is occurring. Host A sends a SYN packet, SYN, to host B. The SYN packet requests to establish a connection, and it's basically saying, hey buddy, you there? And host B responds with an acknowledge, which is SYN-ACK. The ACK is a flag of acknowledgement that the initial SYN request from host A was received. Host B is saying, hey buddy, I got your message, what's up? So they're texting back and forth. Host A then responds with an acknowledge, which serves to fully establish the connection, saying, I acknowledge your acknowledge of my initial request. If these steps complete without error, then the TCP connection is established successfully and the information flow can occur. The following TCP port scans can all be performed by Nmap, which is a tool we're going to, again, cover next lesson. The first type of port scan is a full open scan, which initiates and completes the full three-way handshake. This is a total noob hacker move because a target can detect and log your pen test. Use this port scan only as a last resort. A stealth or half-open scan only completes the first two steps of a three-way handshake. Instead of the final acknowledge, your system sends an RST to terminate the connection. So you still get the confirmation of an open port or a closed port, but no active connection ever is made. The next few port scans all aim to confuse the target system so it drops the packets. A Christmas tree scan floods the target port with packets with conflicting flags. A FIN scan sends packets with the FIN flag turned on. FIN packets are less likely to raise alarm than SYN packets. A null scan sends frames with no flags set. If these scans get no response from the target system, this can indicate that the port is open, while a closed port returns an RST. Finally, idle scanning is when you bounce the scan off another zombie host before hitting the target, so the port scan appears to come from the zombie host. Is that like dodgeball, where you throw the ball off one kid and it hits another kid? I think that's kind of that's how I've envisioned it in my head. That poor guy. Poor Kevin. Anyways, that's port scanning for TCP systems. UDP scanning is much simpler. No response indicates an open port. A closed port returns an ICMP, which is ping, port unreachable message. Okay, we've covered network scans and port scans. Now, the third type of scan is a vulnerability scan, which, as its name implies, is used to identify vulnerabilities on a target system. Vulnerability scans are commonly done internally at companies to proactively find vulnerabilities before hackers can. But hackers can also run these scans. The big problem with vulnerability scanners is that they are designed to look for a specific set of known issues, so they can return a false impression that there are no vulnerabilities on the system. It's kind of like how antivirus works. Most of the time, they're only detecting things that they've seen before. So if something shows up that's new, they're letting it in. We'll cover the vulnerability scanner Nexposé in our next lesson, though you can still use Nmap as a very basic but effective vulnerability scanner. Are you catching on that Nmap is an amazing tool? Nmap is extremely useful. It is truly the king of scanners. So before we talk about the scanning tools in our next lecture, let's review what we just learned. Network scans locate live hosts on a network. Ping sweeps are common. Port scans send carefully crafted packets out to find if ports are open or not. Vulnerability scans find vulnerabilities. Now you know what the types of scans are. Let's learn about the tools that perform these scans.